Okay, good day to all of you. So we're already finished with chapters 1 to 3. Actually, these three chapters comprises the systems planning phase, and now we are already in the requirements modeling, which is included in the systems analysis phase. So requirements modeling is one of the jobs of the systems analyst in this phase. So to know more about the requirements modeling, so let's start our discussion for chapter 4. So the phase description, systems analysis is the second of five phases in the systems development life cycle or the SDLC. We'll use requirements modeling, data and process modeling, and object modeling techniques to represent the new system. We'll consider various development strategies for the new system and plan for the transition to systems design task. The following are chapter objectives. Describe systems analysis phase activities. Explain joint application development or JAD, rapid application development or RAD, and agile methods. Use a functional decomposition diagram or FDD to model business functions and processes. Describe the unified modeling language or the UML and examples of UML diagrams. List and describe system requirements, including outputs, inputs, processes, performance, and controls. Explain the concept of scalability. Use fact-finding techniques, including interviews, documentation review, observation, questionnaire, sampling, and research. Define total cost of ownership or TCO, conduct a successful interview, develop effective documentation methods to use during systems development. So for the introduction of this chapter, this chapter describes requirements modeling techniques and team-based methods that systems analysts use to visualize and document new systems. So this chapter then discusses system requirements and fact-finding techniques, which include interviewing, documentation review, observation, surveys and questionnaires, sampling, and research. So, what is the systems analysis phase? So, the overall objective of the systems analysis phase is to understand the proposed project, ensure that it will support business requirements, and build a solid foundation for system development. You use models and other documentation tools to visualize and describe the proposed system. For this phase, it's more of creating diagrams because it is easier to understand the business processes if it is done or represented using visualizations and diagrams. It's difficult if you're going to list the processes or the business processes. It's easier for us to understand if it is done by using diagrams and other visualization tools. So these are the systems analysis activities. So we have first is the requirements modeling. So for requirements modeling, you have to identify the outputs, the inputs, the processes, performance, and security. So for these are the systems analysis phase tasks. So we have the requirements modeling. Another one is the data and process modeling. And then we also have the object modeling. So these three activities are interacting with one another because if there is, for example, in the data and process modeling, there is an issue that is identified and it needs to return to requirements modeling to see if the issue is valid enough to change the requirements modeling and vice versa for object modeling. So that's why these three tasks are interactive in nature. And then after these three tasks are completed, it will proceed to development strategies. So aside from requirements modeling, we also have of course, the data and process modeling, the object modeling. Okay, for these two modeling, data and process and object modeling, we will study many diagrams that is used in these two modeling techniques. And then we have the development strategies. So development strategies heavily relies on the system requirements document. And then what are the systems analysis skills that is needed for this phase? First is we have the analytical skills because you will need to analyze the business processes and then convert it into a diagram And then you have to identify where does the problem occur in this diagram. And then you're going to create another diagram that describes the solution for the problem that you have identified using a diagram. And another skill that is needed is the interpersonal skills. Why? Because you need to talk to a lot of people, because you're going to interview users, you're going to interview the top management or the managers of how the business processes are done. So this is really very important that you have this interpersonal skills. And then we also have the team-oriented methods and techniques. So we have the joint application development or the JAD, the rapid application development or the RAD, and the agile methods. We're going to discuss these three development methods and techniques one by one in the later parts of the slide. So, first we're going to tackle is the joint application development. Joint application development requires user involvement. So users have a vital stake in an information system and they should participate fully. Why should they participate fully? It is because users or the end users are the ones who's going to use the information system. If this information system does not jive to the user's preferences, then the users cannot effectively use the information system, even if it is created by the most technical, the most intelligent programmers around. So you also need to interview the users of what features do they need to make their work easier by using that system. And then you have to align the features to the user's preferences for ease of use. And then successful systems must be user-oriented. So again, that's why you need to align the features to the user's ease of use of the system. And users need to be involved, of course. And one popular strategy for user involvement is a JAD team approach. So how is this JAD team approach looks like? So for JAD, we have these participants and their corresponding roles. So the first participant is the JAD project leader, and his or her role is develops an agenda, acts as a facilitator, and leads the JAD session. And then one of the key participants also is the top management. They provide enterprise level authorization and support for the project. Of course, they are the ones who's going to approve or deny the continuity of the project, and of course they support the project because they have the financial resource. And the next is we have the managers provide department level support for the project and understanding of how the project must support business functions and requirements. Since managers, they're also knowledgeable of what are the business processes that are happening in a certain office or in a certain part of this company, so they're also needed. And then of course users, they provide operational level input on current operations, desired changes, input and output requirements, user interface issues, and how the project will support day-to-day tasks. So who are the ones who are very intimately involved with the information system? They are the end users because they are the one who are utilizing the system. So the inputs or feedbacks of the user is very important because really they can really narrate the current operations, what are the needed changes for the information system, the input and output requirements required by the information system, and if they ever encounter user interface issues. So users are the ones who are the very best or the first hand, who owns the first hand information of how the information systems works because they're the ones who are utilizing them. And the next is we have the systems analyst and our IT staff members. So they provide technical assistance and resources for JAD team members on issues such as security, backup, hardware, software, and network capability. So again, systems analysts are the ones who's going to analyze and then create diagrams for the problem, for the design. And then the IT staff members, of course, they're the ones who's going to develop the actual information system. And then last is we have the recorder, documents results of JAD sessions and works with systems analysts to build system models and develop case tool documentation. So of course, we also have a documentation specialist for the JAD. So, what are the advantages and disadvantages of using JAD? It is more expensive and can be cumbersome if the group is too large relative to the size of the project. So, this is a disadvantage. It will be more expensive and it will be very complicated if the group is too large relative to the size of the project. And then allow key users to participate effectively. This is an advantage because, as you can see with the JAD participants, all the sectors of the company is well represented. There is no one left behind. There's no office left behind. And then when properly used, JAD can result in a more accurate statement of system requirements, a better understanding of common goals, and a stronger commitment to the success of the new system. This is because, again, the JAD participants are well represented. So that the results, for example, more accurate statement of the system requirements, better understanding of common goals, and stronger commitment to the success of the new system. It's because of the well representation of the participants in the JAD session. Okay, next is we have the Rapid Application Development, or RAD. It is a team-based technique that speeds up information systems development and produces a functioning information system. It relies heavily on prototyping and user involvement. So rapid application development, by the word itself, they're going to create a prototype and then it will be presented to the users, and they will ask for feedback on what are the features that you want, what do you like, or what you don't like on the prototype, and then they're going to change it again based on the user's preferences. So interactive process continues until the system is completely developed and users are satisfied. So the system will considered be completely developed if the users are already satisfied with the features or the functionality that is in the prototype. So these are the RAD phases and activities. So first is we have the requirements planning. So what are the tasks for requirements planning? So users, managers, and IT staff agree upon business needs, project scope, and system requirements. So they have a consortium that they should agree that they have the business needs, project scope, and systems requirements. And of course, obtain approval to continue. So they need approval from the top management to continue. And if it is already approved, next would be the user design and construction. So what are the tasks in the user design? Of course, you have to interact with users because again, you need to align the functionalities to the user's preferences. And then build models and prototypes, and then conduct intensive JAD type sessions. For this is for you to show the functionalities or the prototype to the user. And then next is we have the construction tasks. We have program and application development. It also includes coding, and then it also includes unit integration and system testing. Okay, for every construction and for example, a prototype is finished. So that's why again, this user design and construction are overlapping and interactive in nature. It's because if the prototype is finished to be constructed, and then it will be shown again to the user. And then if the user wishes for or suggest for another feature or remove or add, and then again, they will the development team will construct again. This will repeat. It is iterative in nature, iterative process until the users are satisfied with the functionalities that is already in the prototype. Then if the development is complete or it is completely developed, the IS, then it will proceed to cut over. So what are the tasks for the cut over? We have the data conversion. This is specifically used if the new system uses a new data set different from the old system. And then, of course, is we have the full-scale testing. For unit integration and system testing, which will be discussed on the later chapters. So, this is different. This is testing with the development team. While full-scale testing, you're going to test it in the actual operations. You're going to install it in the computer where the previous information system is installed. And then next is we have system changeover. If full-scale testing is okay, there are no problems encountered, then system changeover will take place. And then if all is already updated, the old information system is not used anymore, it's not utilized, then of course, users, even though they are involved in the development in the RAD, they still need to have user training for the usage of the system. Okay, what are the RAD objectives? So to cut development time and expense by involving the users in every phase of systems development. So this is very helpful specifically for users. What if, for example, you have already completed the system and then you consulted the users and then they have many suggestions and comments on the prototype, and then because it's already almost finished, even the aesthetics of the system, you need to repeat it again, so it's very difficult. So that's why its objective is include the users in every phase of the system's development. Successful RAD team must have IT resources. So they should have these IT resources. They should also have the skills and management support. They will cannot continue if they do not have management support for the approval. And then helps the development team design a system that requires a highly interactive or complex user interface. So for this one, because users are involved, they can develop a highly interactive or complex user interface. Okay, what are the advantages and disadvantages of ROD? So systems can be developed more quickly with significant cost savings. So this is an advantage. You can develop a system more quickly. So you could save specifically for time. And then RAD stresses the mechanics of the system itself and does not emphasize the company's strategic business needs. So you have to have, of course, to include also the top management for RAD. And then might allow less time to develop quality, consistency, and design standards. So this is an advantage. Again, even in less time, you can still develop a high quality, consistent design used for the information system. Okay, next, the third one is the agile methods. So attempt to develop a system incrementally. A Jillian modeling toolset includes support for many modeling tools. Some Agile developers prefer not to use case tools at all and rely on whiteboard displays and arrangement of movable sticky notes. There are also Agile developers that are not keen of using case tools, but instead they want to use a traditional method using whiteboarding and movable sticky notes. So this is an example of agile methods. Actually, if you're going to search to the internet, there are newer agile methods that exist. So this is a very popular one. So we have this Scrum. So Scrum is a rugby term. So inside this Scrum framework, pigs include the product owner, the facilitator, and the development team, while the chickens include users, other stakeholders, and managers. Okay, who are these pigs and chickens? Is this a literal, do you really have to have a pig and a chicken in your company? Okay, this pigs and chickens concept comes from a business fable. Here it goes. Example, you have a breakfast. You have in your breakfast, you have ham or bacon and then egg. Okay. It is said that before you acquire or before you have ham or bacon, you need to kill a pig. While the chicken, you can have you can have the egg, but without killing the chickens. So from this perspective or point of view, you could say that pigs are committed while chickens are only involved in a project. So that why pigs are committed, because for example, if you're going to give their all, they need a sacrifice. They need to make a sacrifice. While chickens, they do not need to give their all for the project. So that's why, as you can see, for the classification of the pigs, include the product owner, the facilitator of, and really the development team, because the development teams are the one who was going to have sleepless nights for developing the software, for coding, for debugging, And then for the chickens, so these are the classifications. So we have users, other stakeholders, and managers. They're not the ones who's going to devote themselves, going to have sleepless nights coding and debugging. So that's why, again, pigs are committed while chickens are involved. Actually, this concept is not used anymore because it's somewhat derogatory or demotivating, specifically if you are classified as chickens. For example, if you're classified as chickens, you could say, how am I going to help in the project? I'm just a chicken. I'm only involved. I'm not committed. So that's why. Pigs and chickens concept is removed in the Scrum framework. Okay, Scrum session have specific guidelines that emphasize time blocks, interaction, and team-based activities that result in deliverable software. Okay, since Agile methods, its purpose is to develop a system incrementally. This is widely used in creating a website or in web development. Okay, Agile method advantages and disadvantages. These are very flexible and efficient in dealing with change, which is an advantage. Frequent deliverables constantly validate the project and reduce risk. This is also an advantage. Because of the deliverables, they always validate the project and entails risk reduction. And then team members need a high level of technical and interpersonal skills. So this is a disadvantage because for you to be a member of a member employing agile method, you need to have a high level of technical and interpersonal skills combined. And then maybe subject to significant change in scope. So this is also a disadvantage because agile methods in the long run can change in scope. Okay, next is we have the modeling tools and techniques. It involves graphical methods and non-technical language that represent the system at various stages of development. So I've said modeling tools includes diagrams and then can use various tools. So we have an example, functional decomposition diagrams or FDD. Model business function and show how they are organized into lower level processes. Actually, FDD resembles an organizational structure because as you can see in the organizational structure, for every person they have this position and that is already describes what this particular person is doing. That's why he has a job title. So that's again, FDD resembles an organizational structure. Okay, another model is we have the business process modeling or the BPM. And then actually business process modeling has a notation. Another example of business process modeling is by using the pull and swim lanes. Pull is an example of a business process and then swim lanes depending upon how many actors are in this business process. Example, you're a customer paying in the cashier. So that process of customer paying to the cashier, that's already a pull. So how are you going to um, illustrate the swim lanes? The customer has its own tasks to do. So that's why he or she has his own swim lanes. While the cashier, once he or she accepted the payment from the customer, he also has some tasks to do. So that's why he or she has a separate swim lanes. The customer and the cashier. But they are also interacting, though the swim lanes are exclusively for the actors of the business process. So that is the business process modeling. So what we're concerned here is the data flow diagram. So I'll not be discussing of how to create a business process modeling. So that this is where we should be concerned more for the DFT. So it shows how the data stores, processes, and transforms data. Additional levels of information and detail are depicted in other related DFTs. On the following chapters, we have a separate topic for data flow diagrams and activities. Okay, another one is we have the unified modeling language. This is widely used method of visualizing and documenting software systems design. An example of a use case diagram, of a UML is the use case diagram. The distinguishable to this use case diagram is the actor. So actually, this is an example of a use case diagram. We have the actor drawn in a human stick figure, a customer, and then we have this use case, which is validate credit card. So before you validate credit card, what is needed from the customer? So we have this, the customer must submit first the card data before the process validate credit card data will commence. So actually, this is a use case. What is a use case diagram? It is a collection of connected use cases. So what if, for example, if you're this is actually very simple. It only describes one task. What if you're going to create a use case diagram for an enrollment system at a university? So it will not just be the customer, but there are also many processes that you have to involve. So this is a very simple example of a use case diagram. And then we also have a sequence diagram. So again, use case and sequence diagram. We will also have a separate discussion for this diagram. So sequence meaning by the word itself. So this diagram is a step-by-step process. It shows or it visualizes the step-by-step process of course, of a business process. Okay, next is we have the system requirements checklist. So we need to identify or we need to create a statement for the outputs as a system requirements checklist. So the outputs, the key term here is they generate reports, displays the outputs or the results. So let's have this first statement. The website must report online volume statistics every 4 hours and hourly during peak periods. So this is considered as a systems requirement checklist for output because it produces an information for the client. So why? The website must report online volume statistics, so your client might be the manager. So that's why. So it has a keyword for report, generate report, display. So this is an example, a correct example of output. Another example. So the inventory must produce a daily report showing the part number, description, quantity on hand, quantity allocated, quantity available, and unit cost of all sorted by part number. So this is an example also of an output because the system is expected to produce. So produce is already an output. A daily report. Another term for output is, for example, print. Print the information, print example grade. So that is already an example of an output. Okay, next is we have inputs. So inputs meaning the statement must describe that you have to have the need of inputting the data into the system. So let's look at the two examples if it's really an input as a system requirements checklist. So manufacturing employees must swipe their ID cards into online data collection terminals that reduce labor costs and calculate production efficiency. So for this example, the main idea here is manufacturing employees must swipe their ID cards. Swiping their ID cards is providing data, that information to the online data collection terminal. So that is already an example of an input as a system requirements checklist. But for example, for this one, that record labor cost and calculate production efficiency, actually, this is a process. But then, if you're going to understand the sentence, again, the main idea here is you are a client, a customer, or a person is inputting data into the system. So that's what you have to remember for input as a requirements or systems requirement checklist. Another example, the department head must enter overtime hours on a separate screen. So the person must enter. So input data. The specific data here is overtime hours on a separate screen. So these two are correct examples of inputs as a system requirements checklist. Okay, next is we have processes. Maybe you'll be confused with outputs and processes. But as I've said, outputs has this keywords such as generates reports, prints, displays, while processes, okay, let's look at the example. So the student record system must calculate the GPA at the end of each semester. So for this example, this is actually a process because you are describing the process to get the GPA. What if you ask, Ma'am, what if it is included in the statement? The record system must calculate the GPA at the end of each semester and generates report for the teacher. For the system requirements checklist, you need to separate if it is an output, if it is a process. So, for example, if this is combined, you have to separate it. So, for example, for this process to be an output, so that's the answer. The student record system must generate reports about the students' calculated GPA at the end of each semester. So that because of must produce daily report, so that would be an input for this one because it should not explicitly describe how it is produced. We only describe the process, the calculation of the GPA. Okay, another example, as the final step in year-end processing, the payroll system must update employee salaries, bonuses, and benefits and produce tax data required by the IRS. Okay, this is another example of processes because what is the process that this describes? Updating employee salaries, bonuses, and benefits, and produce tax data required by the IRS. To make it an output, generate reports or tax data report to be submitted to the IRS so that this will be already an output. But then again, you have to again separate if it is a process, it is a process, and then if it is a an output for a system's requirements checklist. Okay, so these two are correct for the system's requirement checklist for processes. Okay, next is we have performance. So performance means how efficient is the information system in handling data or information. So we have these examples. The system must support 25 users online simultaneously. So this is already a statement for performance because the system is expected to support 25 users online all at the same time. So that's already performance. And response time must not exceed 4 seconds. Of course, this is also a performance because, for example, in a site or in a system, the faster the response, the better. So the threshold is for performance is it must not exceed 4 seconds. Okay, next is we have controls. So controls, it has something to do with limiting the access or having a username and password. So that these are examples of controls. So these are the statements. The system must provide log-on security at the operating system level and at the application level. So this is already a control because we have this log-on security. You need to have a username password so that authorized personnel are the ones who can only access the system. So this is correct. Next is an employee record must be added, changed, or deleted only by a member of the human resources department. So as you could analyze, you can also classify it as a process, but if this last phrase is not included, so an employee record must be added, changed, or deleted. You can consider it as a process, but because you added only by a member of the human resources department, this is classified as a control because by who is the only ones who can add, change, or delete by a member of the human resources department. So these two are examples statements for controls as a system requirements checklist. Okay, next is we have future growth, costs, and benefits. So we have this scalability. A scalable system offers a better return on the initial investment. Why? Scalability means, example, you already have an existing system, and then the users requested for an additional feature, and this additional feature can be added to the system without compromising or without having problems for the existing or the current information system. So it is classified, or it can be considered that your current information system is scalable, because every new feature, you don't need to develop a new information system. Scalability, that is an example already of a scalability, at adding additional features without creating a new information system. So to evaluate scalability, you need information about projected future volume for all outputs, inputs, and processes. So you have to take into consideration the outputs, the inputs, and the processes, because of course scalability, if does not work well, of course it will not be integrated with the current information system. Okay, next is we have the total cost of ownership. The TCO is especially important if the development team is evaluating several alternatives. So which is better, which costs less, which is more cost effective. And then one problem is that cost estimates tend to understate indirect costs. So that's why you have to consider also the indirect costs, such as, for example, the rent of the building, the the bill of the water, or the electric bill. So this that would be the indirect costs. Okay, we have the rapid economic justification, or REJ. So this analyzes and optimize the performance, the economic performance of IT investments. So this is also very important, if does your IT investments really translate to monetary or advantage for the company or not. Okay, next is we have fact finding. Actually, we already discussed fact finding in the previous chapters, but fact finding is just used for preliminary investigation. We are also using fact finding techniques if your proposed project has already an approval from the top management. So you have to dig deeper about the problem that needs to be solved. So that's why you are developing your proposed information systems. So fact-finding overview. First, you must identify the information you need, of course, and then develop a fact-finding plan. Even fact-finding techniques, you have to have a plan. Who, what, where, when, how, and why. Difference between asking what is done and what could or should be done. What's the difference between that? If you're asking what is being done, what is the current operations, or what does the user really do in their daily day-to-day basis of work? And then what is this, what could and should be done? It is more of asking for suggestions or for improvement of the current information system. So these are two different things when asking questions. Okay, next is we have, for the fact finding, we have the Zachman framework. This is a framework for enterprise architecture. It helps managers and users understand the model and assures that overall business goals translate into successful IT projects. Okay, one of the fact finding techniques is we have the interviews. We have the following steps. Determine the people to interview. Okay. It's already discussed in the previous chapter. You can determine the people to interview depending by looking at the organizational structure. But you also be mindful of the so-called informal structures. What are these informal structures? Though they are rigidly following the organizational chart, there may be times that these informal structures, depending on the um, for example, depending on the um, relationship of the employees. Example, we have the president of the company, and he or she has employed his or her son, or his or her, yeah, his or her son. The son started as rank and file, though he's on the lowest part of the hierarchy, but still he or she is the son. or he is the son of the president of the company. So that is an example of an informal structure. Step 2, establish objectives for the interview. So determine the general areas to be discussed. The interviewee must know what is the objective of the interview and list the facts you want to gather. And then step 3, develop interview questions. Creating a standard list of interview questions helps to keep you on track and avoid unnecessary tangents, of course. It's not just scripted, so that you'll be guided. If you are someone who will interview and just throwing questions at random, it will be very difficult to get the facts that you want or that is needed. So these are the you have to avoid leading questions. So what are these leading questions? These are the examples of a leading question. Example, I am the interviewer, and then you are the interviewee, and I ask you, how bad is the relationship with your boss? So, is that a leading question or not? Actually, it is a leading question. Why? Leading questions, this is the definition of leading questions. It's not a technical definition. It's based on what I've understood about leading questions. The interviewer is already insinuating something from those questions so that leading questions can lead to biased responses. So you need to ask neutral questions. So let's get back again to the question that I've asked. How bad is your relationship with your boss? So this is a leading question because as me as an interviewer, I already concluding that you have a bad relationship with your boss. Okay? So how are you going to make it a neutral question? You could make it a neutral question such as describe your working relationship or describe your relationship with your boss. So that is already a neutral because you're not concluding that it is good or you're not concluding that you have a bad relationship again with your boss. So that's an example. Another example, for example, in court. Example, I'm the lawyer. I ask, how fast is the red car that smashed in the blue car? So, is that a leading question? Yes, again, it is a leading question. Why? You are already concluding that, for example, in a court case, the red car smashed into the blue car, meaning that you are already concluding that it is the red car's fault because it smashed. The term or the word smashed indicative of the red car is running too fast. So that's why you are already, by means of your questioning, you are already concluding that it is the red car's fault. Okay, again, how are you going to make a neutral question? Uh, how fast this does these two cars run and collide with each other? So that's already a neutral question because you're not concluding that it is the red car's fault or the blue car's fault because you're asking how fast they are when they collided. So the one who's going to answer the question will narrate of how it really happened. So that's why, for example, if you use the first question, um, you already have a conclusion. So that's why in the court case, sometimes the lawyer will object. The question is misleading. So that's why, because of the construction of the question. So it's always should be neutral, so that you cannot produce biased results. Okay, we have open-ended questions. So these are not answerable by yes or no or by a definite answer. For example, in an identification, it can be it is answered by why and how. Okay, or describe. So that is already an open-ended question. While closed-ended question is answerable by yes or no or a question which has a definite answer. For example, who is the Philippine national hero? Of course, it's Jose Rizal. So that's already type of a close-ended question. And then we also have a range of response questions. Range of response, of course, you have choices. It's set of like a multiple choice question. Okay, next is we have step 4, prepare for the interview. Careful preparation is essential because an interview is an important meeting and not just a casual chat, of course. Especially if you are interviewing an employee with a high position in the company, would you wear casual clothes? Of course not. With respect to the one that you're going to interview, you need to prepare even the best clothing that you have. And then limit the interview to no more than 1 hour. And then send a list of topics to the interviewee so that he or she will also be prepared for the answers and not an ambush interview. And then ask the interviewee to have samples available. Okay, step number 5, conduct the interview. Develop a specific plan for the meeting. Of course, again, fact-finding plan, it must have a plan. Begin by introducing yourself, describing the project, the reason why you are doing the interview, and of course, explaining your interview objectives is already included in there. And then we also have this engaged listening. So engaged listening, you really must listen to the one that you are interviewing, to the interviewee. And then allow the person enough to think about the question. Okay, let's go back to to engaged listening. So that's why some interviewers have these follow-up questions because they're really intently listening to the interviewee. And then allow the person enough time to talk about the question, to think about rather. Of course, do not make them answer abruptly. Even though you send a list of topics, especially what if your question is a follow-up question. So you need to give time to the interviewee to think about the answer to your follow-up question. Since follow-up questions, there are questions that pop up when depends on the answer on the questions that you have sent. And then after an interview, you should summarize the session and seek a confirmation. So we have these minutes for the interview. You need to send it to the interviewee and seek confirmation if these are really the information or the data that the interviewee has really said. So that's why you need to seek a confirmation. Okay, step 6 is document the interview. So, note taking should be kept to a minimum because it might distract the interviewer if you're always interviewee if you're always taking notes, saying listing or writing the words verbatim. Okay, what if for example, ma'am, if it is note taking to be kept in a minimum, um can we record the whole interview? You can record, but you need to ask first the permission of the interviewee. Because sometimes in the time of the interview, sometimes the interviewer, there is a term off the record. Off the record means though he is sharing the information to you, but you don't have to write it down or take it down because sometimes this information that he or she has shared is very confidential, and off the record means you cannot disclose it to other people. And then after conducting the interview, you must record the information quickly. So that's why note taking should be kept to a minimum. After the interview, send memo to the interviewee expressing your appreciation, your gratitude for giving you time and accommodating you for your interview, even though he or she is busy. And then note date, time, location, purpose of the interview, and the main points to discuss. So the interviewee has a written summary and can offer additions or corrections. So that's why, for example, for the interview, before you submit, for example, to the management, you need first to seek confirmation for the interviewee if it is already correct or if he or she will add additional information or some data or information that you have forgot to indicate in the minutes. Okay, step 7, evaluate the interview. In addition to recording the facts obtained in an interview, try to identify any possible biases. It should be neutral. Okay. There are, of course, interviews that are not successful. So no matter how well you prepare for interviews, some are not successful, such as, example, you are already scheduled for that interview and then the interview is not available at that time, or he or is sick, or he has um, a leave from the office, or he has something to do. So there are times that there are really unsuccessful interviews. Okay, aside from interviewing, what are the other fact-finding techniques? Is we have the document review. If the company has a documentation of their business processes, you can already search there, research there, and then the problems that you can encounter. And then next, we have the observation. Seeing the system in action gives you additional perspective and a better understanding of the system procedure. You can use observation. Plan your observations in advance. Okay, so it can be announced or unannounced, but you have to have a schedule of your observation, specifically if you, as a systems analyst, are not part of that company. You cannot just gate crash or barge in. You have to have an appointment to them. And then we have this so-called Hawthorne effect. So Hawthorne effect is um, the quality of work changes while you are being observed. Do you have any experience of that? For example, if you are being observed, sometimes you become better because you are being observed. You cannot make mistakes. But sometimes the other effect of that, because you're being observed, you are being nervous, that in your actual day-to-day work that you are not observed, you're very good. But why on that day when you were observed you made a mistake? Because you are nervous. So that's the for the Hawthorne effect. um, the persons who are observed are affected because of the observation. But sometimes if it is announced observation, sometimes it becomes very mechanical, because since you know you are being observed, sometimes it is not really how you work. So sometimes they are not observing directly. So that's why all of them are already, for example, installing CCTV cameras, so that even though they are under observation, they can still act freely because there is no one directly observing them at work. So that's the Hawthorne effect. Okay, another fact-finding technique is using questionnaires and surveys. So when designing a questionnaire, the most important rule of all is to make sure that your questions collect the right data in a form that you can use to further your fact finding. Sometimes, actually, in a very good setting for using questionnaire, actually questionnaires or in surveys, they have this dry run. It's not yet the actual survey. You have this dry run to make sure that the right data is collected. Sometimes you think that your questions are already okay, but when you put it in the dry run, there are data that should not be asked anymore, and then there should be a data or information that it should be included in the survey. So it's very important to have a dry run. Okay, you could use a fill-in form, especially nowadays. You could create surveys using Google Forms. It is very effective, especially if you're going to make surveys online. It is already very used, and of course, it is free. Okay, we have sampling, another fact-finding technique. We have the systematic sampling. For example, you have a population of 100. A multiple of 5 uh, will be sampled. So that's the systematic sampling. Stratified sampling, example, CIT department. You have four years, first, second, third, and fourth, example. And then you need 40 participants. So to distribute it for the 4 years, you need to have you need to have 10 persons each for the years, for 10 for first year, second year, third year, and fourth year, so that the population is properly or well represented in the sampling. And then we also have, of course, random sampling. In the word itself, you will select your respondents by random. So the main objective of a sample is to ensure that it represents the overall population accurately. Okay, another one is the research. It can include the internet, IT magazines, and books to obtain background information, technical materials, news about industry trends and developments. And then research it's not limited with just the internet, magazines, and books. You could also research through site visit. Okay, which is better to use, interviews or questionnaire, or do they have a certain advantage or disadvantage, or in what situation you're going to use an interview or a questionnaire? So this is the ideas. So interview is more familiar and personal, so that's why interview is usually most for qualitative researches. And then questionnaire gives many people the opportunity to provide input and suggestions. So then questionnaire is used more in quantitative research. And then we also have brainstorming. We have two types for brainstorming. We have structured and unstructured. For structured, for example, you're a group of 6 people. There is a question and then you are asked one by one in order. So that's a structured brainstorming. Unstructured brainstorming, again, you are composed of 6 people in a team. Structured brainstorming, there's a question and then who's going to give an idea without the order. So that without the order, and you can throw ideas, you can suggest without any order or sequence to be followed. So that is an unstructured brainstorming. Okay, next is we have documentation, the need for recording the facts. Record information as soon as you obtain it. It's better, a better memory reception is not just watching, though we are classified as visual learners, but to reinforce our learning, we have to record information, we have to write. There are studies that shows that this particular concept, for example, has a better memory retention if you're not just watching, but you're also taking it down. And then use the simplest recording method. And then record your findings in such a way that they can be understood by someone else. Of course, your writing should be legible and readable. And then organize your documentation so related material is located easily. Okay, you could also use software tools such as case tools and productivity software such as word processing, spreadsheets, database management, presentation graphics, and collaborative software programs. So collaborative software programs, as an example, is Google Docs. You can edit your docs with your team simultaneously at the same time. And then histogram is for showing the data. And then the graphics modeling software. So this is an example for software tools for documentation. Personal information managers. For example, the contacts information, that is already a personal information tool. And then wireless communication devices. Example, our smartphones, they have this diary, we have this notepad, Wunderlist, and the like. Okay, next is we have preview of logical modeling. At the conclusion of requirements modeling, systems developers should have a clear understanding of business processes and system requirements. Of course, they're the ones who's going to create the system, but before that, they should understand clearly the business processes and system requirements. The next step is to construct a logical model of the system. IT professionals have differing views about systems development methodologies, and no universally accepted approach exists. So, we're already finished for the chapter summary. So, the systems analysis phase includes 3 activities: requirements modeling, data and process modeling, and consideration of development strategies. The main objective is to understand the proposed project, ensure that it will support business requirements, and build a solid foundation for the systems design phase. The fact-finding process includes interviewing, document review, observation, questionnaires, sampling, and research. Systems analysts should carefully record and document factual information as it is collected, and various software tools can help an analyst visualize and describe an information system. So, if you do not have any questions, thank you for listening, and please subscribe. And if you have any comments or questions about the discussion, you can freely ask me. Thank you very much and good day.